Hey everyone, welcome back to my channel, and in this video we are going to solve this problem on LeetCode, which is third maximum number in array. So we are given nums array and we need to return third distinct maximum number in this array. So if it doesn't exist, then we can return a maximum number. So um, let's go through the examples given and understand the problem more clearly and provide some approach to solve the problem and then move to coding part. So we're given this array and this is maximum, and this 3 is maximum, our maximum, and this is our second maximum, and this is our third maximum, right? So, and in this case the output would be third maximum. In the case where third maximum doesn't exist, for example, if we are given a size of array with a size of 2, then we can return 3 instead of 2 or anything else. So we can return max. Or if we have this like 3 2 2, then we can return max as well in this case. So one possible solution that's coming to my mind is, so we are given an array, it's not mentioned, it's sorted, so 3 1 2, let's say, just to uh, make the order random. And in this case this is our maximum, so the biggest one, second biggest one, and third biggest one, and this is our answer. So our first approach is sorting. So basically we are going to sort our array, so it will look like this: 1 2 3. Doesn't matter, the sorting will be in ascending order or descending order. Then we can just start from the end and iterate through array until we find our third distinct maximum. For example, let's say we are given array with this kind of values, and after sorting we'll have an array with these values: 2 2 2 and 3, and then this is our maximum, the last index, and we move to the left and we found our second max here, and if we go even uh, more back, so then it's still the same, it's equal to our second maximum. If we go here, it's still second maximum, and finally if we go here, then we found our third maximum and we can return this. In case it doesn't exist, our pointer on the left, but we found only two maximums, so in this case we can return our first maximum here. So the time complexity of the solution is O of n log n. The space complexity of this solution is O of 1, because we do sorting in place. I would definitely ask from interviewer whether we can change the contents of given array or not. So as it's not explicitly mentioned, do not change the input array, then we can change it, we can sort it. So this first approach is sorting, and second approach is, approach number 2 is iterating the array 3 times to find third maximum times. So we are given the same array with this example, like 1, 3 twos. So we are given 1, 2, 3, 2, 2, and 3. Or it doesn't matter. So in first iteration, we find our maximum, which is 3. This is O of n operations. And in our second iteration, we try to find second max that's less than 3. This is also O of n operation. And in our third iteration, we try to find our third maximum, which is less than second. This is also O of n time complexity, and the time complexity of this solution is O of n, and space complexity of this solution is constant as well. So this is our solution. So I think the second approach is better one, both in terms of time complexity and same constant extra space needed as first approach. And then we can just start coding the second approach. So let me open the editor here. So we are given array, so let me copy the example. Okay, let's maximize it. Okay, and then let's get started. So let in first iteration find max. So can we have, so it's never empty, so we can say that our max is num's first element. So for I in nums, if I is bigger than max1, then max1 is I. So this code we found our maximum, and now in this second iteration we need to find our second maximum, and x2. So here as well we need to have initial value for our second maximum. So in here, let's initialize with minus infinity, and for I in nums, if I is bigger than mx2 and I is smaller than mx1, then mx2 is equal to I. So in here we can also rely on the very first element. And what if this first element is max itself? So yeah, it's better to rely on minus infinity, right? And third max, we also do the same operation here. Could definitely move it to the separate function. So this time it should be bigger than max 3 and less than max 2. In that case, we update the value of max 3, and if max, then how do we know max 3 is updated or not? Let's find our minimum value in here. In our very first iteration, if I is less than minimum, then minimum is equal to I. So we can start with our minimum value as already. So now we already have values for maximum 2 and maximum 3, the values that are all already in array itself. So once we found our second maximum, if max 1 is equal to max 2, that means we don't have distinction, so we can immediately return max 1. No need to search for max 3 because it will be equal to max 1 and max 2 anyways. So, and then you can also check if max 2 is equal to max 3, then return max 1 and return max 3 finally. And can do this and minimum, let me go through my code and validate and make sure it doesn't have any syntax errors. So I'm good with the solution. Let me run this specific example here. So we're saying minimum and maximum is 3 for now, and finding maximum and minimum. So minimum and maximum 3 and 1, and our second max, it begins its journey from value 1, and then if I is greater than maximum 2 and less than maximum 1, greater than 1 and less than 3, in first iteration this condition isn't met. In second iteration it will be 2. In the third iteration it doesn't met. And great, so this condition isn't met, and we are trying to sort trying to search our third maximum, and this code looks good to me, and let's run it. So yeah, this is our final solution. This has of n time complexity and uses constant extra space. Thanks for watching. See you in the next videos.